this solution that we came up with to reduce the latency of the data, since we cannot do anything about the speed of light or the latest advancements of fiber optics cable. The only thing that we can do that is in our control is reducing the distance that our data has to travel, and in turn that will affect the latency of the data. Now, how do you achieve this? That's where content delivery networks come into place. The whole idea behind a content delivery network is this thing: reducing the distance that a particular piece of data has to travel in order to reach a user or to a server. And the way it works is, let's say we have origin server here. This is server, and this is where our clients are, basically users who are going to use our platform. You can think of this as desktops, phones, tablets, whoever the users in your platform are. These are the users, user, and this is our server. Now, the way communication, since we are talking about HTTP here, not any other kind of communication, the way HTTP communication works is clients and servers have to send requests and responses back and forth. So this client will send a request and this server will send a response. We are oversimplifying it. Of course, there are other pieces of communications, other flows of communications here, like the three-way TCP handshake, the TLS certification check, etc., etc. But to oversimplify it a bit, to not focus on the networking side of it and to keep it on the backend application side, we are going to assume that we are doing a normal round trip of a network. So users will send requests and servers will send responses. And same way with all these other users. Put it here, and the server sends responses. Same here, and the server sends responses back. And these are traditional data communication architecture. Now the problem is this server can be in any location. And since most of our cloud providers, for example, AWS to be one, they are mostly based out of US, particularly San Francisco. Let's imagine this server is in SF, San Francisco, and the users are all over the world. This can be in India, and this can be in China, and this can be, let's say, Norway, right? Users, the platform's users are spread across the world, and the server is in San Francisco. This is where the problem is. This is where we discuss the issue of data latency. Every network round trip has to be made between thousands and thousands of kilometers. That is the problem, and that is where we see the latency. To fix this issue, in order to get around this problem of distance between clients and servers, what comes to your mind? Naturally, if you try to think about it, if you want to reduce the distance, either you cannot take the clients closer to the servers, because that's not possible. You cannot ask all your users to move to San Francisco. What we can do, we can move our servers closer to users. And how can we do that? That's where the concept of CDN comes from, which is content delivery network. Now, the idea of CDN is these cloud providers, of course, not every company can afford to build its own CDN. Building a CDN, which we'll discuss in a bit, what it will take for you to build your own CDN architecture, your own infrastructure to build a CDN. And that is not a very smart path for a company to go towards. So of course, a company, if it wants to make use of a CDN technology, it will obviously go for a existing cloud provider, something like AWS. Now, the idea of CDN is this: you have your server and you have your users. CDNs, what they do, if we can zoom out a little bit so that we can understand this architecture better. Let's do one thing. We can spread this across, so we'll understand the concept of distance a little better here, and this is here. Same way, we'll move this somewhere around this. Okay. And let's say our server is here, a more realistic distance. And let's zoom it out a little bit more. Yeah. And we take a fair amount of space here. And this will be here. This here. This will be here. For the sake of this example, we'll just think with 3 clients, 3 users, and the server will be somewhere around here. Okay. And this server that we are talking about, this you can imagine as a auto scaling server. This is not a single instance. You can imagine that there are multiple instances of our server that is serving at this location, which is in San Francisco. And the distance from here to here is, like each country will have a different distance, right? But we can assume that all the distances are at least 15,000 kilometers for the sake of this example. Now, how do we understand the CDN part of it? Okay. Now, these are our requests and responses for servers. Now, the idea of CDN, as I said, is bringing the servers closer to your users, closer to where users are requesting the data, so that data will have to travel less distance. Now, what happens when you take this service of a CDN technology from any cloud provider? What happens? That cloud provider, so let's say a cloud provider like AWS. AWS has its own servers spread across the world, and we call those locations, all the locations that AWS has servers, as edge locations. Edge location has a different meaning than just spreading your server in different countries or different cities. We'll get back to it in just a bit, but let's understand how CDN works on a very high level. Now, AWS as a cloud provider, since it's a big cloud provider, it has data centers and servers spread across the whole world. If you take a CDN service from AWS, what happens? Whatever data, or let's say you are requesting a static website, whatever data that your clients, your user requests, they don't go to your origin server directly. The requests go through the AWS's edge locations, the AWS CDN nodes, CDN servers. So you can imagine, since the idea of CDN is bringing the servers closer to users, say it's a CDN node. So AWS has its own CDN edge node closer to each user that is requesting data from your server. Okay. Now what happens? When a user requests some data, some kind of asset from your server, the request actually goes to the CDN node. Our architecture changes from this point, and we can imagine that. So what we did, we added one more hop in between our requests and responses. Now what happens? A user from India requests some data. Since we are talking about a Next.js site and a website primarily, then let's say a user from India requests a HTML page, an HTML x.html. Okay. Previously, what used to happen, the request will go from India all the way to San Francisco, and the server, our origin servers from San Francisco, will return the index.html back to India. Now what happens? When the user requests the index.html, it will go to a CDN node, and that CDN node will check if it has that particular data, in this case index.html. If it has that data in its own cache, that is a keyword to note here. CDNs are basically cache servers. If the CDN has that data in its cache, it will check if the cache is expired or not. If it is expired, what it will do, it will make a request to our origin server, and after the origin server returns the response, it will return that response back to our user. Okay, that in that case you will not see a major improvement in your data latency. But assuming if you request some kind of asset and that asset is already present in your CDN cache, then it will immediately send that asset back to your user. Now, the advantage that we saw here, this CDN node, this edge node, initially our origin server was around 14,000 kilometers away. Now, this edge server, this edge node that we are talking about here, which we rented from an AWS service, this, let's say max to max, it's around 500 kilometers. 500 kilometers. This is the distance between any average distance we can talk about, even if it's a remote location inside India. An average distance between a user and a cloud provider's edge location can be around, on average, 500 kilometers. Now, going by our initial calculation, let's say the speed of light in fiber optics cable is 200,000 kilometers per second, and now we are talking about 500 kilometers. So if we divide this by 200,000, what we get is 0.0025 hits. Now that is around 2.5 milliseconds. So from our earlier calculation of each request, if we see here, each request was taking around 120 milliseconds. Of course, we also have to take into account the congestion in the network and any hurdles that our data packets face while transmitting from one location to another. Even if it is a shorter distance, even if you consider that, the maximum we can get here is 10 milliseconds, and that's us being generous. 10 millisecond is for making one trip from one location, the location of your user, to one edge location. And initially, how much did we have? We had around 120 milliseconds. So that is a reduction of more than 10x. That is a significant reduction in latency. 10 millisecond is not even observable by the user. Of course, HTML is not the only asset that a user has to fetch. For successfully rendering a page, a user has to fetch the HTML, then it will find out all the JavaScript assets in the CSS files and images files, etc., etc. Right? But max to max, it will be able to fetch whatever resources it has to fetch under 100 milliseconds, which is not that observable to a normal user. So this is the primary advantage that we see for when we are using a CDN technology. The primary functionality of a CDN technology is to distribute data by being present closer to the users, so that data does not have to travel thousands and thousands of kilometers, and which will again affect its latency. Another important thing to notice here is I mentioned this term. Let's zoom in now. I mentioned this term called edge location. Now, edge location, this is a term that we borrowed from networking. In networking, you will see this a lot, usually referring to some kind of edge device, some kind of repeater, some kind of switch which connects one block of a network or one network topology to another network topology. It's a networking term. But in terms of infrastructure, when we are talking about backend technologies and cloud technologies, what edge locations mean is the way data, the way internet works, in fact, is we have all our countries. We have all our countries here, and each country, of course, has multiple ISPs. ISPs basically your internet service providers, and they have multiple ISPs. And the way we connect one location to another location so that they can transmit data between each other is cables, of course. And these cables are often installed undersea. These are called undersea backbone cables of our internet infrastructure. And these are not the only connections that we have. For example, if we are talking about cloud technologies like AWS, since AWS has been around for a long time and it has a major impact on internet's infrastructure, AWS has its own backbone cables that connects all its major data centers, and it also connects all its major CDN edge locations so that it can control all the factors that affect in data transmission, like speed and latency and congestion and how to route DNS traffic, everything. Now, what do we mean by edge location is, since each ISP has to connect with other ISPs so that it can pass on data from one location to another location. It does not matter if what ISP the user uses at the end of the day. All the ISPs, all the major organizations, and all the major data centers are connected to each other through private backbone cables or the major undersea backbone cables. And the definition of edge location is, there are points, and these points are called IXPs. It stands for Internet Exchange Points. These are basically all the connection points when there is some kind of infrastructure installed there, and it routes data and traffic from one major exchange point to another. It's some kind of connecting point. And there, in that location, these major cloud technologies and these major CDN providers, they have tie-ups with these ISPs. And since these are the points where major organizations, major ISPs transmit data between each other, and this is where the routing, the major part of routing happens from one big chunk of location to another big chunk. That's the reason if you have servers installed here, some kind of compute installed here, some kind of smart data processing logic installed here, and you have some kind of control here, and you have also some kind of storage here, then since all the requests from users, here we were talking about users, all the requests from users from all different locations, all their requests, since this is the major routing point, all their requests will go through this. Of course, this is not the only IXP, there will be other IXPs along the way. So this will be something like this. We will be here, and there can be another IXP somewhere around here. Now, some users' data will go through this IXP, and other users' data might go through this IXP. This user's data might go through this IXP. It does not really matter though. The point I am trying to make here is, since these are the points, the exchange points where major decisions in data routing happens, if at this point you have control over how and what data you are storing, you can send the fastest response to your users, because it is the edge of a network. And there is a reason the term edge is used here, because edge is, it's basically literally edge of the location. After this, another edge starts. This is the connection points of one network, and it is the edge of that network. That is the reason edge locations is used a lot. And edge location is not the same as your server, your cloud provider, or your company having its own data center in a particular location. Edge locations are usually applied in the context of CDNs, because CDNs have to strategically place their servers, their cache, closer to the users. And the best place to do that is Internet Exchange Points, and in collaboration with ISPs, your internet service providers. That's the whole idea of CDNs. Now, to talk a little bit of history of CDNs, since we are getting deep into the context. CDNs came around 1990, and it was initially an attempt to improve the web performance issues. If you have watched my HTTP video, there we go through the history of the web, at least in the context of HTTP. And as you already know, during the initial years of internet, to be more precise, during the initial years of HTTP, there were a lot of scaling issues, there were a lot of performance issues. Around 1990, the research started for improving the performance, for scaling of the internet infrastructure. And one of the major companies which had a big impact on CDN technologies is, and we can see the website. So this is the website, and this is one of the major CDN providers till now, and it has the largest POPs in the world. POP is basically points of presence. at all the edge locations that we are talking about initially, those are called POPs, points of presence, and it is a term that is used more in the context of CDNs. And Akamai, it was founded in around 1998, and it was one of the major CDN providers, one of the only CDN providers at that time, and now it is one of the major CDN providers because it has been around for a long time, and it was founded by some MIT researchers, and it was the first commercial CDN service. And eventually, of course, once one company started offering its technology, started offering its service in CDNs, other companies also followed. And around 2008, Amazon introduced its CDN technology, which is CloudFront, one of the major parts of Amazon's infrastructure. It's CDN, and its name is CloudFront. And this blog goes deep into how, when, what of CloudFronts. It was published in 2023 on the anniversary of 15 years of releasing CloudFront. It has a lot of internet details. If you want, you can go through this to understand Amazon CloudFront a little deeper. Then one of the other major CDN providers around 2009, it was Cloudflare. During the time it came up, they were not, of course, one of the largest CDN providers, but now, since Cloudflare started, so if we go to Cloudflare blog, let's see here, and we go to the last page. So here you can find the first blog post of Cloudflare, where they mention about starting this company, and it started out as a CDN company. And you can see the first data center being installed in different locations inside US. And Cloudflare started primarily as a CDN company and a security-based company to provide security for internet-based cyber attacks like DDoS and security issues related to TLS, SSL at that time, etc., etc. So since then, Cloudflare has managed to expand its network all over the world, and it is now one of the major CDN providers, which comes after this. CloudFront, of course, with Amazon AWS resources, is also a major CDN provider, but Cloudflare is considered one of the fastest when it comes to data latency in its CDN offerings. Majorly, if you see now, Cloudflare still is a CDN and security-based company. Okay. Now, what are some major use cases of CDNs in the first place? The first thing that, as we talked about, caching data assets and synchronizing between your origin server and your users to make the whole experience faster. The first thing is caching static assets. And we are talking about static assets here. So far, we are not talking about any type of compute, any kind of execution, just a dumb static asset caching mechanism. If you ask for a file, it checks if it has the file. If it does not have the file or the cache has expired, it makes a request to the origin server to get the file, or if the cache is expired, it makes a request to get a latest file, and it sends the file back to the user. Static files. We are talking about fixed static files so far. Now, what else? Second thing is traffic routing. Now, one of the offerings of Cloudflare, if you see, is it protects you from various security risks like distributed denial of service attacks or any kind of internet traffic based attacks. And if you go through different blog posts of Cloudflare or their docs, you will find this information repeatedly, that the reason Cloudflare is able to protect you from these kinds of attacks is they have such a large scale spread of edge nodes and edge locations that whatever attack that might happen on your servers, and it does not matter what the scale of that attack is. In one of the blog posts, they discuss one of the largest scale DDoS attacks was still significantly less impactful on a Cloudflare network. And the reason they're able to protect you and they're able to evade these network attacks is because of their edge nodes. They are able to equally distribute all the traffic between their edge nodes, and they are able to siphon off all the traffic, and you are safe from any kind of load on your server and any kind of traffic outburst, right? So that is one of the major offerings of a CDN: traffic routing and load balancing traffic. AWS also has its huge CDN network. That's how Route 53, its DNS offering, AWS's DNS service, works by efficiently routing traffic between different nodes and different locations. Okay? So one of the primary advantages of a CDN provider from their side is, since they already have this huge span of nodes all over the world, now they can offer various kinds of service, not just delivering content. They can also provide other kinds of service because they have this power, because they have these resources to offer these kinds of services. Next is, as I said, offloading demand. When you have a huge traffic outburst or when you're facing some kind of DDoS attack, they're able to neutralize that kind of traffic because of their nodes that is spread all over the world. That is another use case of CDN, right? Security services. We also have video streaming. Video streaming, of course, also falls in the category of content delivery. But since its mechanism, the way it works is a little bit different from serving static assets, it deserves its own category. So if you watched videos like how platforms like Netflix or Hotstar, these streaming platforms, these OTT platforms, they're able to live broadcast these major cricket events like India-Pakistan match, etc., right? If you go to the YouTube and search for how Hotstar handles millions of users for its live broadcast, you will find a lot of resources. And CDNs are, of course, a big part of that architecture. And usually, if you can read more about it, but the way it works is the live broadcast. So they use formats like HLS. So it divides your videos in different encoding formats, and it makes chunks out of these, etc. It's a rabbit hole. You can explore more about that. But the core idea of how CDN comes into this place of video streaming is these, wherever the source is where you are uploading the live broadcast, they upload these videos, the video stream. Of course, it's not a large video file. It's a continuous stream of data. Those streams are uploaded live into some kind of platform, some kind of architecture. And then, of course, they are down the lane, they are made into chunks to deliver to clients or to save in server, right? And these chunks, they are cached in CDN servers so that when the users, let's say you are watching the match, you see some amount of buffering and it's longer than usual, but you are finally able to see that video because your origin server sent data back to your CDN and your CDN streamed it back to your client, right? That's a normal use case. But the next time a next user requests for the same chunk, for the same, let's say some milliseconds of video, if we are talking about chunks, that chunk is already cached in the CDN server. So that can immediately send it back. So that user will not see or will see very minimal amount of buffering. Okay? That's how it works in the video streaming architecture. CDNs play a huge role to make the experience as real time as possible and as fast as possible. Now, theoretically speaking, if you as a company, if you have the resources, if you want to create your own CDN infrastructure, if you want to build a CDN infrastructure like Cloudflare or CloudFront from scratch, then what are the things that you will have to do? First thing is, of course, you have to have a global presence. Need POP, point of presence, is basically having your server closer to users, right? Whatever the location that is, the edge location globally, right? Without having your servers closer to users, without having the actual infrastructure servers, you cannot build a CDN. The whole point of CDN is having your servers closer to users. So that is the number one point. And with each servers also, you cannot just install any kind of systems, right? There has to be some kind of requirements. for a CDN to work as efficiently as possible. So each POP, each edge location, each point of presence that you want to build closer to users, they should have robust network connectivity, right? For fast network transmission inside cables, through cables, high bandwidth uplinks, whatever equipments, network equipments that you're using, switches or bridges, or repeaters, whatever. Next thing is hardware and networking. Now here, each of your point of presence should have very high performance servers, because they will need a lot of CPUs, they will need a lot of RAM, and they will also need a lot of storage in fast SSDs. You cannot use, I mean, you can use traditional hard drives, but since you are offering CDN services, and the whole point of CDN services is reducing latency, you cannot have latency causing factors in your own system. So you cannot provide traditional hard drives. You have to go for SSDs and fast SSDs, so that doing any kind of IO operation inside your system is fast enough, so that you can promise your users that you are able to minimize their latency. You will also have to choose networking gears like routers, etc., with hundreds and thousands of GPPs. Then you have to run your own BGP, border gateway protocol. Now this is one protocol which plays a major part in DNS routing. You don't have to understand how it works and all, but just can remember that BGP is one protocol which plays a big role in routing traffic inside internet. And you will need your own DNS servers, DNS with Anycast routing. Now, all these CDN providers, this Cloudflare or CloudFront, they have DNS routing functionalities, but they work on Anycast routing. We have different types of DNS routing. We have unicast, we have broadcast, we have Anycast, etc. Anycast, the whole idea of Anycast is you have servers who share the same IP, and those servers are in different locations all over the world. So if a request comes for a particular server, then through BGP, through border gateway protocol, that request can be routed to the nearest server of the user, or the server which is active for that request. Since all the servers share the same IP, that's why BGP, the border gateway protocol, is able to route that request to the appropriate server, to the fastest server. And that kind of routing, having a single IP, having multiple servers sharing the same IP, etc., that architecture is called Anycast routing. And this is one of the patterns that a lot of CDN technologies use these days. It's kind of a default. You cannot have a CDN without Anycast routing, because DNS routing is one of the major latencies of data transmission from one point to another. Okay, so that's one. Or if you don't want to have your own DNS Anycast routing with servers and all, you can of course use existing service like Route 53 from Amazon. It offers DNS services with Anycast routing and all. You can make use of that to focus on your own CDN infrastructure instead of going into the DNS route. Then of course, we also need the software. You cannot have a CDN server without proper softwares to manage the whole data flow. In software, what do we need? Of course, since we are talking about caching, since we are serving static assets, we'll need some kind of web cache. We have a couple of famous ones. We have Nginx, we have One, we have Apache server. These are all static servers. These are all reverse proxies or static content serving servers and caches, right? Basically. So you have to have one of these or a combination of all of these, whatever your software architecture is, you have to plan it out. That is going to be the major part of how the request coming from user is decided to be served using a cached content, or it should routed through an origin request, etc. These softwares are going to take care of that. Of course, you have to build your own logic, your own CDN server logic on top of these softwares. But yeah, you get the idea. Then you also have to think about an operating system. So you'll probably go with something like Linux. So that's one of the first choices for hosting a server. Then you also have to think about Edge Compute, right? We will come back to this shortly after this discussion. This is a major part of understanding CDN, at least in the context of understanding Next.js based CDN functionality, edge compute. You have to take care of how you are going to offer edge compute services. Now, typically, edge compute, when we say edge compute, at least from the patterns of all the cloud providers that currently offer edge compute based services, they use V8 based runtime. In the previous video, in the serverless, we talked about how Cloudflare workers run on V8 runtime, right? And Cloudflare workers are an example of edge runtime. Since now this is an interesting topic, edge runtime, because Cloudflare, since it started as a CDN service, eventually what it realized, since it already has so many edge locations, so many points of presence all over the world, the next thing that it can provide its users is the ability to modify the cache. And since CDN servers, primarily what they do, they cache your static contents, and when the user requests it, they serve it. But what Cloudflare thought, what if we provide the users the ability to interact, to ability to program that part, the user requesting the content and the CDN cache sending it. In between that, if the users are given some kind of programmatic capability so that they can modify the content, they can decide, they can modify the caching logic, they can modify or interact with any external requests or databases, etc. Right? There are a lot of possibilities, infinite possibilities. And that's where the idea of Cloudflare workers was born. So if you look up, this is a blog post introducing Cloudflare workers. We saw this in the previous video, and they announced it around 2017. And Cloudflare workers are one of the primary examples of edge compute. You have a major CDN network, and in those edge locations, in those points of presence, you are providing your users some amount of compute, right? Some kind of compute, in, of course, depending on their pricing tiers and all. The resources of that server, of that compute technology will vary. You might have less CPU if you are on a less pricing tier, etc., but users are getting some kind of compute, some kind of logic, some kind of programming ability near that edge location. And that fact that users are getting this ability to program how these CDN edge locations, content serving in these CDN edge locations, to have some kind of control over that, that changed the equation a lot. Previously, using CDN, you minimize the data latency of serving static content from one point to another. Right? Now, what happens? You can run code, any kind of programming logic, closer to your users. Previously, what used to happen, you have a user in India and you have your server in San Francisco. So in order for server to do some kind of computation, the client has to make the request from India to San Francisco during, let's say, using an HTTP request. Now the server will start processing and the server will return the response, right? That latency. Now, if we forget about the static part, this computation part also has a factor of data latency. So let's say the user made the request, and taking from our earlier example of 120 milliseconds, which takes for one trip from India to San Francisco. So one request took 120 milliseconds from India to San Francisco. Then the server took some amount of processing, right? So let's say around 150 milliseconds of processing it has to do. So maybe it had to make some kind of database call, maybe it had to make some kind of file operation. After that, it returned the response, and that took around 120 milliseconds back. Right? Now what happens, if you are able to provide some kind of compute to the users in CDN locations, in edge locations, now what happens? The equation completely changes. We have this. Now we come here, this 120 milliseconds from our earlier discussion, this becomes 10 milliseconds, and this also becomes 10 milliseconds. Now the total latency is around 170 milliseconds. Previously, how much was that? Around 240. It was around 400 milliseconds. So now from 400 milliseconds, you are 150 milliseconds, which is not even the half of it. But this was the revolutionary idea. This was the idea of edge compute, this term, edge compute. This had a major impact on a lot of technologies, a lot of frameworks. We'll come back to this edge compute a little bit later. Now we are still talking about what it takes for you to build your own CDN infrastructure. And we are over with the softer side. Then we also have to talk about the protocols and of course security. This is a major part. Since you are offering CDN services to your clients, they are going to expect security from it, and you have to care a lot about security for offering a service like CDN. Right? So you have to support modern protocols like HTTP 1.1, HTTP 2, HTTP 3, which is also called Quick, and TLS 1.2, TLS 1.3, and you have to do regular vulnerability testings and regular checks for your security, and you have to be very, very secure. You have to be prepared for anything, because websites, when they are targeted for cyber attacks, especially traffic-based cyber attacks like DDoS, etc., CDNs are expected to take care of that. One of the reasons companies use Cloudflare is to avoid being attacked, or even if they get attacked, Cloudflare is expected to evade that as a CDN provider. You also have to provide some kind of firewall. Since you are kind of a first responder for any kind of user traffic, CDNs often offer firewall features to filter out any kind of malicious traffic, any kind of cyber attacks, etc. Not just traffic-based cyber attacks like DDoS, also malicious cyber attacks. And this list will go on and on. You'll have to think about operational challenges. You have to think about ISP and IXP tie-ups, because you cannot build CDN architecture without tying up with ISPs and IXPs. And you have to tie up with other cloud providers to offer smooth integrations, etc. The list will be very long, right? And you'll need millions and billions of dollars and years of time to build and establish a CDN infrastructure that is even close to Cloudflare. And that is one of the reasons it does not matter if you're an individual or a company, you should never think about building your infrastructure. You can make use of these existing cloud infrastructures like AWS and cloud. I just wanted to bring this up to better understand what it takes to build a CDN infrastructure, to better appreciate it, to also understand some of the internals of it, right? So now let's move on to something else. When we are talking about CDNs, and this topic will come a lot when we are finally reaching the Next.js side, which is caching. Of course, CDNs and caching go hand in hand. And when we are talking about caching, at least when we are talking about caching on the internet, when it is concerned about the web, one thing which plays a big role is cache control. We have a header, it's called cache control. So let's see, you will see this a lot in pretty much every website. So let's do a reload, and for this file, if we look at headers, you will see that there is a header called cache control and it says no cache. What it means we'll understand shortly, but this is a very common header and it affects a lot of user experiences, a lot of processing in browser, in proxies like CDNs and different places. Now, what is the use of this header? It has different values. Each header, as you know, in HTTP can have a key value pair, right? The key is cache control and it can have a value, and the value will be, of course, be a string, and it will be separated with commas. Now, in the values separated by commas, there can be multiple values. There can be multiple entries. The first entry, which you are going to see, is it's either going to be a private or public. So if we copy this, it is going to look something like this. A column here, and let's move it to here. So the first part is either going to be a private or public. Now, private means this content. So this usually comes in response headers, the cache control, and it makes sense in response headers from servers. Now, if you got a response from a server with some kind of content, it can be a static file, it can be an API call, etc. In the presence of this header and with this value, what it's saying, if it says private, it means that this content, whatever content that is served in the response, this can only be cacheable by the client. And client in this case is the browser. And the reason it exists because of this technology like CDNs and these proxies. So whatever technology that comes in between from the origin server to the client. So there can be CDN providers in between. So if you write private, it means that any CDN provider, any kind of proxy that comes between the server and the client, it should not cache it. And usually CDN providers respect this header It's kind of a standard. You cannot build a CDN technology without respecting standards. It has to work with other providers, other technology at the same time, right? And that's the use of private. And if it says public, then it can be cacheable by any node. It can be cacheable by CDNs. It can be cacheable by your browser. And browsers also understand and respect this header. And there we have, let's say, comma here. Then another entry that we have is max age. Max age. Now this is expressed in seconds. So you might, if you get something like 60 here, initially cache control was built for the browsers because there were no CDNs and all. Now it says that the browser should cache this content for 60 seconds. And what that means is, in these 60 seconds, if another request comes for the same content, the browser is allowed to serve the same content without making another request to the server, so that it can save some amount of data latency. And the response will be much faster because of this caching. That's what it means. After 60 seconds, after 60 second is exceeded and another request comes, then what happens? Then the browser has to make a request to the origin server and it has to check if the content has changed from that point or not. Now, this is where, if you have watched the HTTP based video, where I think we have talked a lot about e-tags, HTTP based caching, and if modified since, etc. etc. These headers play a role in that whole workflow. Those are the headers, if modified since or e-tags, etc. etc. Using those headers, the browsers and the servers can share information on whether that particular piece of content has been changed since the original request or it's still the same. If it's still the same, then the browser will continue to serve from its own cache. If it has expired, then the server will send the updated response and the browser will cache that again for 60 seconds. Now, usually CDNs also respect the max age header value, which means that this whole interaction between browser and the origin server will happen between CDNs and the origin server and browser and CDN. So max age can be used by both CDN proxies that exist between the origin server and the client and browsers at the same time. We also have another value. It's called S max age. And here we can have values, right? And the point of this value is only CDNs are allowed. A response has some structure like this. So it says cache control, and you got this response from your server. It says public max age equals to 60, S max age equals to 120. This means that for this response, for this piece of content that is being served in this response, this can be cached by your CDN proxies, whatever exists in between. By them, it can be cached for 120 seconds. And for browsers, it can be cached for 60 seconds. Now what happens after 60 seconds, since the cache is expired, the browser has to make a request to the server. Now, of course, that request will go through the CDN, and the CDN, since it is configured for 120 seconds, it will still serve the cached content without making a request to the origin server. So this is how it works. S max age is particularly intended to be respected by CDNs, right? And this header, this cache control header, this header plays a very big role in how your server can control how much the response can be cached by the CDNs, by the browser, etc., to provide a near real-time experience to the user. Give an experience where you can, even if there is data latency, by using this caching technologies in between, you can make it feel like the latency is less than it actually is. Right? And understanding this cache control header is very important, especially when we get to the Next.js part, because that heavily makes use of this cache control header to provide different experiences like ISR, like incremental static site generation flow. There you have the revalidation flow, and that revalidation flow makes use of this cache control header behind the scenes to provide that infrastructure level caching experience. Now let's talk about the one last final piece of information in the context of CDNs, which is going to be very important later on when we get to the Next.js part. Of course, we have covered it in this video also, in the previous video also, which is edge compute. You must have heard this term a lot, especially in the Next.js ecosystem or the Vercel Next.js ecosystem. And these days, a lot of front-end frameworks talk about this a lot, edge compute. As I said, edge compute basically means that bringing the ability to give your users the feature of programming their caches or programming their servers and placing that whole workflow near users, right? Since you are a CDN provider, you have all these different servers spread across the whole world, right, near the users. Now, the only logical thing to do at this point is, instead of making your CDN nodes dumb, it's dumb in the sense that it does not do any kind of computation. It does not have any kind of logic in it. You ask for a resource, it gives you the resource. So the next logical step for any CDN provider, any cloud provider, is to add the feature of compute in your CDN nodes, so that with the advantage of having your static assets delivered with minimal data latency, you can also provide the feature of having your compute with minimum latency. Right? Even if we are not talking about any kind of assets, compute also incurs the cost of latency, right? So that is the whole idea of edge compute. Now the second, so let's write down. First idea is provide compute closer to the user to minimize latency. Now the second thing is interceptor for user experience. Now, by this second point, what I mean is a CDN node which has the capability of compute. The user can add some kind of programming technology to it and can do some kind of processing for each client request, given that the ability to program it. And the second point, the definition of a CDN node being that the first point of a user request will go through your CDN node because of how strategically CDN nodes are placed. So as we saw here, CDN nodes are strategically placed in the edge locations. Edge locations basically meaning the connecting points of different major networks. A user's request will first go through this point. And at this point, if you have some kind of processing power, then you can quickly make some change, or you can quickly return some response also. And that will have the minimal amount of latency as compared to if you did the same thing, let's say in a different data center or in a different location that is on the opposite side of the world. Now, with these two characteristics of CDNs and edge compute, in the modern times, people have come up with a lot of use cases. One example of this interceptor based use cases, let's say your website is built with the language English, which most websites are built with, but you also have a different content for other languages also. Let's say you have the translation based service and you have internationalized your content for different languages like French, Germany, Hindi, etc. Now what you want to do is, let's say you have a user in Germany and your server is in India, right? And by default, what happens? A user from Germany makes a request and your server sends the response back. Now in this equation, we have already introduced the concept of CDNs. Now that request will not go to your server, go to your CDN. And since that content is cached, your CDN will return the response back to the user. And that content will served by the CDN. Now what happens? Let's say there is no concept-wise compute here, of course. It is just a normal CDN to serve static content. Now, we already have a content which is particularly suited for a German. The content is in German language. But since our CDN does not have any thinking capacity, it cannot tailor that response as per the user. But assuming that we have the feature of edge compute, now what happens? We get the request here and we can write some logic here using JavaScript. And the reason I'm saying JavaScript is because we already know that in edge locations, most of the cloud providers, at least that's how it is at this point of time, most of the cloud providers, and I'm talking about mostly AWS and Cloudflare workers, at edge locations, of course, AWS has another service called Lambda Edge. We'll get to that in a bit. But in edge compute, when we are talking about edge compute primarily, then it is mostly JavaScript based and it is mostly V8 based, JavaScript V8 based runtime. We have discussed this part extensively in the previous video, so I won't get into this in this video. But yeah, you will write your code in the JavaScript and you will check that if the user's accepted language is in German, then what you can do, instead of serving the English content, you can serve the German content directly. And since this logic is in an edge location, which is closest to the user, and it is strategically placed at an internet exchange point location, this interaction is very fast. So the moment user types your domain name in their browser's URL, and the moment they hit enter, they'll be instantly returned a German content based response, as compared to, let's say, our traditional approach where you make a request to the CDN and the CDN sends back an English response, and now the user has to manually select the German response, then now the CDN sends back the German response. That is when we don't have edge compute. But since we have this feature called edge compute and we can strategically place computations in these edge locations, we have a lot of features open to be explored. And Next.js, with its new features, encourages and uses edge features, edge compute a lot, and you will see edge compute a lot in Next.js blogs and Next.js docs, etc. It's great. Now let's talk about some solid technologies, right? Since we've been talking about theory of how CDNs work, how edge compute works, let's talk about some solid technologies. Primarily at this point, I'm assuming that you have already watched the previous video, which was about serverless technologies, where we talked about Lambdas or Cloudflare workers, etc. Now, we already know that AWS has a serverless platform called Lambda. And we also know that AWS has a very extensive CDN, which is CloudFront. CloudFront is AWS large CDN network, which is spread across the whole world in different cities and remote areas. Given these two offerings, what AWS did, it offered another service which is called Lambda Edge. But Lambda Edge is also a serverless instance. The only difference is if you invoke a Lambda function, it is going to run in your default AWS region or whatever region that you have configured with. Now, AWS regional data centers and CDN nodes are not the same thing. So you can imagine that CDN nodes are closer to the users as compared to the regional data centers. So if a distance from a user and a CDN node is around 100 kilometers, a regional data center will be around 1000 kilometers or 600 kilometers. So an edge node, a CDN based edge node is always going to be the closer to the user. Now, what AWS did, it offered the feature of Lambda, the booting of serverless instances in edge locations using its CloudFront extensive CDN network. So now instead of your Lambda instances being invoked in regional data centers, they can be invoked in edge locations. That's how AWS proceeded. And that is one of the reasons AWS was able to offer different languages. Like it offered JavaScript and it also offered Python. Right? These are the two offerings of Lambda Edge. Lambda Edge was announced around 2017, right? But Lambda Edge was still a firecracker based serverless infrastructure. That means the JavaScript and Python, the JavaScript one ran in a Node.js instance and the Python on the Python runtime, right? This was typical serverless infrastructure. The very low latency promise of a edge compute that was still not there with Lambda Edge because of its Node.js server instance and the firecracker based infrastructure, right? It was still not to the point. It was still not at the state what is expected from an edge compute. Edge compute based responses are expected to be in the range of 0 to 5 milliseconds, right? Extremely low latency. responses. And that's why around 2021, AWS also announced something called CloudFront functions. Now, CloudFront functions, the difference between Lambda Edge was this also ran. So this is also a compute based technology, and Lambda Edge is also a compute based technology. The only difference is now CloudFront functions made use of JS V8 engine for its edge compute based technology. Now, as we have already discussed, JavaScript V8 engine is extremely fast in booting up, and it is extremely concurrent and extremely secure, etc., etc. And of course, it's very, very efficient in saving cost and saving resources, etc. Now, with the integration of JavaScript V8 engine in CloudFront functions in its CDN edge locations, now AWS was ready to offer the edge compute expected features like extremely low latency and very fast boot time, almost 0 millisecond cold start using CloudFront functions using JavaScript V8 engine. Now, at the same time, Cloudflare workers, they were announced around 2017 at the same time when Lambda Edge was announced. But from that point only, Cloudflare made use of JavaScript V8 engine for its service, which was called Cloudflare workers, is Cloudflare's edge compute based offering. And that is the reason from the day one only, Cloudflare was able to offer edge compute with 0 millisecond cold start time. And of course, both of these use JavaScript V8 based runtime, which means that in edge compute, you cannot use a lot of APIs. You cannot use Axios, which is based on XML HTTP request. You cannot use file system. You cannot make TCP connections from your edge compute instance to a database. You have to use serverless databases, etc., etc. There are a lot of limitations, but this is all about edge compute. Edge compute is the whole idea of edge compute being providing the ability of programming to your users with very less latency. Right? All the advantages of a CDN, of a static asset serving CDN, now you just added compute to it. That's what we mean by edge compute. Now, since we talked all about this, let's try to summarize everything, right? So that we can wrap our head around all these concepts. What exactly happens in a request response lifecycle with its all the CDN nodes with edge compute, etc., etc. Now, first thing, your user makes a request and your user's browser looks up the site's DNS. So let's say it typed example.com. Now it's your browser's responsibility to find out what is the IP address of this particular domain. Now what happens? Let's say we are talking about CloudFront, AWS CloudFront. Now what happens? CloudFront's DNS or Cloudflare's DNS, it can be Cloudflare also, they return the IP address of the nearest POP. Since these CDN services used Anycast based routing, we discuss Anycast based routing, which basically means that multiple servers which are spread across a location will have the same IP, and whichever server is closest to that user, that server is going to be responsible to send or serve content to that user. So the CloudFront's DNS or Cloudflare's DNS, they will return the IP address of the closest point of presence using Anycast routing. Right? That is the first thing. What happens next? Second thing, at this point we have reached the edge location. At edge location. Now what happens? If you have written some code, you have written some kind of serverless code that is supposed to run at this point, then that code will run, and that code has the ability to modify a couple of things. Now it can modify the URL, it can modify the cookies, it can modify the headers, etc., etc., before either serving the content back to the user or making a request to the origin server. The edge function, whatever code that you have written, it has a lot of features. It has the ability to do all these things. This is where the edge function, the edge compute, actually executes after your request reaches the edge location. Then what happens? Then of course the cache lookup, the edge node, whichever node is serving your user, it checks if the requested object, whatever content that you are requesting, if it is present in the cache and it is fresh at the same time. If it is expired, then of course it has to make a request to the origin server. But if it is present, and if it is not expired, then it will always send the response back to the user. But if it is not cached, it is a cache miss, then the edge node will proceed to the next step to fetch the resource. Then what happens? Origin request, of course. Since it was a cache miss, you have to make a request to the origin server to get the content or to get the latest content if the cache was expired. Now at this point, if there is an intermediary cache, now AWS has these regional caches. This is your user. Now this is your user. This, let's say we make it round. This is your edge CDN node. Your edge CDN node which is serving a request, and this is your server, which is very, very far. Now, in some instances, at least in the case of AWS, what happens? Before this CDN can make a request to the server, what happens? There can be other caches which are called regional cache. AWS has this feature called regional cache, which basically means that before it reaches your server, it can have another layer of cache which might have your content. So your edge node will actually make a request to there instead of to your origin server. If that also does not have your content, then that will make a request to your server. So as you can see, these cloud providers, they try to make a lot of optimizations to reduce the amount of requests that actually reaches your server. In the same way, Cloudflare also has a concept called tiered caching, which is kind of same as AWS regional cache. It says that before your request can go to your origin server, it will go to a higher tier cache, which might have your content, so that one less request will be made to your server. So these things happen in a typical cache miss based workflow. This is how a request response looks like in a CDN / edge compute based workflow. Now, all these things, they are kind of abstract because I am trying not to bring up Next.js based concepts in this video, because I just want to clear up some fundamentals. Even if I am not able to clear up the fundamentals, since I am mentioning these words again and again, because of that, when in the final video, when we'll be actually talking about what happens inside Next.js and Vercel infrastructure, there, when I mention these words, you might have at least 10% context of what I am actually talking about, instead of being completely clueless. But that's the whole point of this video. So I'm just trying to make you familiar with what all infrastructure we have available that Vercel uses internally to provide you this nice user experience, to provide you this powerful features. Now, before this, while talking about edge runtimes or edge compute, I mentioned another thing, which is serverless databases. Even though this is not directly connected to how Next.js and Vercel infrastructure works, but if you have recently built any app using Next.js or have explored any of the open source repositories which uses Next.js, you will see that these projects are using databases, managed database services, something like Neon or PlanetScale, let's say Supabase. Right? These are all serverless databases, and I think Supabase also has an offering for a serverful connection. But in a typical Next.js based app, it is recommended, even in the docs, if you see, it is recommended to use one of these managed services, or if you see open source repositories, then most of them are either using Neon or PlanetScale or Supabase. The reason being, since Next.js, of course, I'll only be giving some kind of brief here. Since Next.js, at least when you're deploying it in Vercel, runs completely on serverless infrastructure. And it also deals a lot with edge compute, at least in recent developments. You cannot use your traditional databases. Traditional database, by traditional database, I mean, let's say you rent an EC2 instance or any kind of VPS for $5 or something like that. And you install Postgres there, or you install MySQL there, and you expose that port and you connect to that database server using your server, etc. This is how our traditional servers connected to databases. This is how you used to host, and you have to manage that whole database yourself. Now, in a managed database, you just go to this services like Neon and PlanetScale. You just type your database name and your ready-made You are just provided with a connection URL, and using that URL, and they also offer their own drivers, and using popular ORMs like Drizzle and Prisma, you can connect to the database, etc. etc. But one keyword that appears here a lot is serverless. And there is a reason the concept of serverless database is brought up a lot in the Next.js ecosystem. And at least when we are talking about edge compute, it is even more significant. And the reasons are some of the limitations of our traditional database server-based approach, where you rent a VPS or some kind of virtual machine and host your own database and manage it, and your servers can connect to the database using TCP connection. In that workflow, and the workflow where you used a managed database like Neon, PlanetScale, or AWS service like RDS, DynamoDB, there are some key distinctions between these two workflows, and it also involves some limitations of our traditional serverful database servers, and there are also some limitations of our serverless databases or managed databases, right? And all these things are very important, because when you're using Next.js, you can go with your own, which I mentioned, VM or VPS based own hosted database server, but you also have to take into account a lot of things so that your server does not crash and you can keep it running. All these things are very important if you are going to work with Next.js, or if you are going to understand projects which work with Next.js. Serverless databases play a very important role in a Next.js based app. So that is the reason we are going to talk about serverless databases in the next video, and we'll explore all these different things that I mentioned. What are the limitations of our traditional approach? What are the limitations of this new serverless approach, this managed database approach, and all the key internals, all the key behaviors, etc., etc. And after that, we'll finally reach our last video, which talks about Next.js and Vercel. We'll bring up all these different concepts that we've been talking about in the last 3 videos. All the concepts about serverless technologies, on the concepts about CDNs, edge nodes, edge locations, and the concept of serverless databases. All of them together will help you to get a very holistic understanding of the Next.js ecosystem and a Next.js project deployed in Vercel infrastructure.